Welcome back to Science Modernizers. In today's video, we are going to see the problem on the famous H equation, that is Lord James' birthday equation. So the question goes as thus: on Mr. Lord James N.B. birthday, the 21st of March 2023, Miss Januarine and Chamberlain, being so eager to know Mr. James's new age, sent him a message wishing him happy birthday, and then Januarine kindly asked, "Sir, would you mind if I ask how old you are?" Mr. Lord James, being marveled and happy, replied positively to the message on the birthday wishes. On replying the question based on his age, he kindly said, "My age is A," where A is given by the equation A is equal to the sum as arrow runs from 1 right up to infinity of 1 divided by arrow plus 2 all squared plus 68 divided by 3. So in general, what does the question demand? What is Mr. Lord James' age? A, and hence deduce the day he was born. So what do you think we can actually do in this video? So let's proceed in the next part and see how to solve the famous age equation. So let's get started. So this is the problem statement, and we definitely see from here that we have a sum. So A is an expression of a sum that goes right up to infinity. In general, it is a series plus 68 divided by 3, which is a constant term. So how then are we going to solve this problem? We clearly see that the only way which we can actually solve this problem is for us to determine a possible value of this sum. So the possible value of this sum can actually be deduced using some methodologies. So we have to determine, number one, if this sum either converges or diverges. So what then is going to be the result of this sum? Now we know that if a sum converges, then at the end the limit of this sum at infinity will always be L. But if it diverges, then we are going to have a value at infinity. So in general, for this sum which we see, we are going to pass through the integral test method in order for us to deduce the value of this sum which goes right up to infinity. So we are going to consider 68 divided by 3 as a constant. So we'll mostly work on this and evaluate this result, then sum it up to 68 divided by 3 and see the final result. So let's get the proposed solution to this. The first step is I'm going to let S to be this sum, the sum as arrow runs from 1 up to infinity of 1 divided by arrow plus 2 all squared, and this implies that our age A will simply be this, which is now a certain S plus 68 divided by 3. So how do we start? In order for us to evaluate this, I am going to let LR, I'm going to define LR to be a given function, that is to be 1 divided by r plus 2 all of that squared. And now we want to use the integral test to verify if this sum converges or diverges. Now what are the criteria used in the integral test? The first is, in order for us to use the integral test, the following criteria must be true. The very first is the sequence must be positive. So the sequence should be a positive sequence. And which sequence are we talking about? 1 divided by r plus 2 all squared. This should be a positive, So the next is the LR should be a decreasing function. A decreasing function simply means the derivative is negative across a given interval. And next is the function should LR should be continuous. So in general, we clearly see that for this sum S, R starts from 1 right up to infinity. So we can deduce that R is greater than or equal to 1. In other words, R is found in the closed interval 1 right up to the open interval at positive infinity. So let us define now this function in terms of x in order for us to deal with familiar things. So if I let L of r to be equal to f of x, where f of x is equal to 1 divided by x plus 2 all squared, and we clearly see from here that x should be different from -2, because at this point this function will not exist, and this is a vertical asymptote to this function, and therefore it is a point of discontinuity. So we notice that since r here takes value from 1 right up to positive infinity, then necessarily x should be greater than or equal to 1, telling us that x can take values from 1 right up to positive infinity. So let's get started. Let's verify these criteria. Now, is LR or is f of x positive? Question. So what do you think it can be? Will this function be positive over this domain which we have defined? Actually, so f of x is defined as 1 divided by x plus 2 all squared, where x should be different from -2. We clearly see that if we plug in any value inside this function, definitely we are always going to have a positive value, since if any value squared is always positive. So definitely yes, it is in the interval 1 right up to positive infinity, since it is our interval of concern. But this is definitely positive throughout the whole set of real numbers, including the point -2. So we are mostly interested in the region x greater than or equal to 1, since that is a specified region defined by the sum. So it is positive in the interval 1 right up to positive infinity. Now the next is it decreasing? So we are going to use the derivative test in order to verify if this function is increasing or decreasing. So we are going to assume that it is decreasing. So if it is decreasing, it definitely means that the first derivative of the function is negative. So if the first derivative of the function is negative, we can then conclude that the function is decreasing in the given interval. So let's obtain the first derivative of this function. So f prime of if f of x can be written back in the form x plus 2 raised to the minus 2, that is from the laws of indices, and if we differentiate to obtain the first derivative, we simply bring down this -2, that's it there. The next is you differentiate what is inside, you get this one, you recopy back this function, and you subtract 1 from the power. You can also use the quotient rule in order to calculate this derivative. So basically this is the chain rule. So the next that we can obtain is simplifying this. You see that -2 times 1 gives -2, and -2 minus 1 gives -3, and definitely f prime of x can be written in the form -2 divided by x plus 2, all of that cube. So basically we can already argue this if it is decreasing in the interval which we are really interested in, that is 1 right up to positive infinity, or for x greater than or equal to 1. You see that for x greater than or equal to 1, x plus 2 is going to always be positive, and therefore x plus 2 cube will always be positive. 2 divided by a positive number will always be positive, and times a negative value, now see that it is always going to be negative, which we can conclude that it is a decreasing function. But let's try to study this on a real number line, considering that we are on the set of real numbers, and see how this function is going to behave. So basically, if we represent the critical point of this function on a real number line, we see that the critical function of this derivative is occurs at x equal to -2. So at x equal to -2, in general, we have a change of slope, that is from negative right up to positive. And if we test values from -2 right up to positive infinity, we clearly see that from negative infinity right up to -2, we clearly see that the function is increasing, whereas from -2 right up to positive infinity, the function is decreasing. So basically we see that since the function is decreasing from -2 right up to positive infinity, we can also deduce that the function is decreasing in this domain 1 right up to positive infinity. So what then can we say? Hence f is a decreasing function. So we see that two criteria have been met already in order to use the integral test. So let's verify the next: continuity. What's the meaning of continuity? It simply means that continuity in simple terms means if I can draw a function without lifting up a pencil, for example. Yes, drawing a smooth curve without lifting up a pencil. So let's see if this function is continuous throughout its domain. So basically f of x is 1 divided by x plus 2 all squared, where x is different from negative 2. But we clearly see that negative 2 is a vertical asymptote, and therefore it is not continuous at this point, negative 2. But one thing we observe is negative 2 is not found in our domain. It is not found in our region of interest. So therefore, it definitely tells us that in between 1 right up to positive infinity, this function will exist and it's going to be continuous. Hence, continuity is verified. F is continuous in the interval 1 up to positive infinity. So that is the arguments which we could give for these three possible conditions. And since these three conditions hold, then we can apply the integral test. So applying the integral test on the interval 1 right up to positive infinity, we have that I, if we define I to be the integral from 1 right up to positive infinity of 1 divided by x plus 2 all of that squared dx, then one can say that I can be the integral from 1 right up to positive infinity of x plus 2 raised to the minus 2 dx. And this we can define it as a limit. That is, we are going to remove this indefinite point above in the upper limit, and we are going to define I to be the limit as j tends to positive infinity of 1 raised of from 1 right up to j of x plus 2 raised to the negative 2 dx. So what can we then deduce? If we change variables of this integral, then we are going to let u to be x plus 2 from where, if we differentiate this statement, we get du to be equal to dx. So definitely replacing this in the integral, we get that the integral of x plus 2 raised to the negative 2 dx is simply equivalent to the integral of u raised to the negative 2, since u is x plus 2 raised to the negative 2, dx is equal to du. So we get that integrating it, we simply use the power rule of integration, which is going to give us u to the negative 2 plus 1 divided by negative 2 plus 1, which is u to the negative 1 or negative 1, which definitely gives us negative 1 divided by u. But replacing u by x plus 2, we get that the integral of x plus 2 raised to the negative 2 from 1 right up to j is equal to negative into 1 divided by x plus 2. From we compute it in the boundaries from 1 right up to j. But remember, if we substitute the limits, that is upper limit minus lower limit, we get this statement. And getting this statement, evaluating now the limits, since we had an integral right up to positive infinity, and we took the limit of the integral and we replaced the positive infinity bound by j, then evaluating the limit, we simply get that I will be the limit as j approaches positive infinity of this statement of this function. Now you clearly see that as j approaches positive infinity, 1 divided by j plus 2 tends to 0. Since as j is increasing, the value on the numerator remains a constant, so 1 doesn't change. But as j keeps on increasing, for example 1000 divided by 1000, sorry, 1 divided by 1000 plus 2 is 1 divided by 1002, which is very small. And as j keeps on increasing, 1 million, 100 million, you clearly see that this ratio tends to 0. So definitely as j tends to positive infinity, the quantity negative 1 divided by j plus 2 tends to 0, and we clearly see that we'll be left with only negative into negative 1/3, and therefore we can conclude that I is equal to 1/3. And since the limit is finite for the integral test, it definitely tells us that that sequence or that series converges to 1/3. And if using the integral test I converges to a given value L, then it definitely means that the sum too converges. So since I converges to 1/3, then the sum as r runs from 1 up to infinity of 1 divided by r plus 2 all squared also converges to the point 1/3. But notice, we knew that A was given as the sum as r runs from 1 up to infinity of 1 divided by r plus 2 all squared plus 68 divided by 3. So definitely, can we get the value of A? Yes. So deducing the age of Mr. Lord James, we clearly see that this sum converges to 1/3. So if you take 1/3 plus 68 divided by 3, the denominators are the same. So you sum of the numerators and it gives you 69 divided by 3, which gives you 23. So therefore, we can deduce that the age of Mr. Lord James is 23. So this actually brings us to the end of this first part of the question. Now the next part of the question asked us to determine the year which Mr. Lord James was born. So for us to deduce the day which he was born, we are simply going to use the fact that the birth date was given in the question, which was March 21st, 2023. Then the born day will simply be the difference between this actual year, that's a current year, minus his age. So we are going to have the born date to be 2023, that is the actual year, minus the age, which gives 2000. And therefore, according to the question, Mr. Lord James was born on the 21st of March 2000. So thanks for watching. Please like, share and subscribe. See you in the next video. And on the next video, we are going to have a physics lesson on data analysis, which is actually uploaded already on the channel. So the link shall be shared, and please do not forget to like, share and subscribe. Science modernizers, modernizing the educational world.